Math 2, Key Features from 3 Quadratic Forms. This graphic organizer highlights the key features that are easy to identify without having to do calculations from each of the 3 quadratic forms. Standard form is f of x equals ax squared plus bx plus c. So we're going to be using the example function shown. Let's start by listing the a, b, and c values. So as you can see from the generic form, a is the number in front of the x squared. So right here, a must be 2. B is the number in front of the x. So negative 4 is the b value. Notice how the negative sign goes with that number. C is the constant in the back. So c is equal to negative 6. So there are 2 key features that are super easy to find from standard form without having to do any calculations. Those 2 key features are the y-intercept and the concavity. So for the y-intercept, just if you're in standard form, it's going to be 0, comma, c. So it'll just be the number in the back. And that basically happens because if you're looking for a y-intercept, it means that you're on the y-axis. So since you haven't moved left or right, your x value is 0. So when you plug 0 in for x, everything cancels out except for the c value in the back. So our y-intercept would be 0, comma, negative 6. For concavity, it's always looking at the a value in the front. And the cool thing about concavity, it's the same no matter what form you're in. So standard form, vertex form, factored form, the concavity is always the same. You just look at the a value, so the number in the front. If the a value is greater than 0, or if the a value is positive, it's going to be concave up, so it would look like that. And then if the a value is less than 0, so if a is negative, it'll be concave down, so like that. So when we look at our example, since a is 2, 2 is positive, so this is concave up for our example function. The next form is vertex form. So the generic vertex form is f of x equals a times quantity x minus h squared plus k. So let's go ahead and label our a, h, and k values. Since a is the number in front, that negative sign, that's a negative 1. So a is going to be negative 1. H is right inside the parentheses, but notice there's a built-in minus sign in the original generic function. So when I look at my example equation, h is actually negative 2, not positive 2, because h is supposed to be the number behind a minus sign. So h is actually the opposite of the number you see inside the parentheses. So h is negative 2. Basically, I could have rewritten this as negative x minus negative 2, like that. So h would be here. It's the number after the minus sign, and that double negative turns into the positive. If you got a little lost there, easiest way I think to remember it, the h value is just always the opposite of the number you see in the parentheses when you're in vertex form. K value is in the back. It's followed by comes after a plus sign. So the k value, you don't have to worry about switching the signs. You just use the number in the back. So if it's positive, keep it positive. If it's negative, keep it negative. So whenever you're in vertex form, there are 3 things that are super easy to find: the axis of symmetry, the vertex, and the concavity. Axis of symmetry is simply x equals whatever the x-coordinate of the vertex is. And when you're in vertex form, your vertex is always h, comma, k. So your vertex would be negative 2, comma, 4, and then your axis of symmetry is x equals negative 2. Concavity is super easy. It's the same for every form. Just look at the number in the front. So in our case, a is negative 1. Since negative 1 is negative, you want to say it's concave down because a was negative. Last form, factored form. The generic form is a times x minus r sub 1 times x minus r sub 2. So let's label our a value and our 2r values. So a is the number in front. So right here, a is -2. R sub 1 is here, but remember, be careful. Look at your generic form here. You have built-in minus signs, meaning the R values are the opposite of the numbers you see in the parentheses. So your R sub 1 value is actually going to be +1, and then your R sub 2 value is actually going to be -3. And again, the reason that happens, I could rewrite this as -2 and then times x minus 1 times x minus -3. So in this case, the R value is -3 and the other R value is +1. And again, if you get a little bogged down by that second function I wrote in purple, just always remember it's the opposite of the number inside the parentheses for your R values, just like it was the opposite of the number inside the parentheses for the H value in vertex form. So on our example for our two x-intercepts, those are going to be the R values. So we have 1, 0, and then we have -3, 0 as our two x-intercepts. Concavity, since a is -2, this is going to be concave down. So on the back, there's just a bunch of practice with these. So why don't we do the first one together, and then I would say pause the video, do the rest of them, and then check your answers. And I re-put the forms up at the top of the second page. That way, ideally, you don't have to scroll back and forth as much. So with these problems, you're going to state the form and determine all of the key features that are easy to identify from that form without calculations. So we'll do one together. So when I look at this function, I see one set of parentheses being squared as opposed to no parentheses like you see in standard form, or factored form has the two sets of parentheses being multiplied together. So this is going to be vertex form because it has the one set of parentheses being squared. So key features from vertex form, I can do my concavity. So I'm going to say concave down because of the -2 as your A value. I can get my axis of symmetry. I'm going to be lazy and say A of S for axis of symmetry, and that's going to be x equals whatever the H value is, or whatever the x coordinate of the vertex is. So that would be the opposite of the number inside the parentheses. So x equals 3. And then the last thing that's super easy to find from vertex form is the vertex. That's why it's called vertex form, because it's easy to find the vertex. So vertex is H, K. So remember, K is your number in the back. H is the opposite of your number in the parentheses. Just a little before you pause the video and try all of these, just a reminder. So standard form is no parentheses. Vertex form, one set of parentheses being squared. Super easy to find the vertex. That's why it's called vertex form. And then factored form is your two sets of parentheses being multiplied together. And when you look at it, it's a trinomial that has already been factored. So that's why it's called factored form. It's a trinomial that has already been factored for us. So try the rest of these. All right, now that you've tried them, number 2, I see a trinomial that's already been factored. So this is factored form. It's the two sets of parentheses being multiplied together. For key features, we can get our concavity really easily. So it's concave down because of that -A value. That negative sign is like a -1. And then the other thing that's super easy to get from factored form are your x-intercepts. So my x-intercepts are going to be the opposites of the numbers in the parentheses. 1, 0, -3, 0. Number 3, that would be standard form. There's no parentheses. It's just all, ax squared plus bx plus c. So that's standard form. It's going to be concave up because our A value would be an invisible 1. And then the other thing that's super easy to find from standard form is our y-intercept. And our y-intercept is always the c value in the back. And that only works for standard form. People try to make that work for the other forms. It only works for standard form, that you can just look at that number in the back and know that that's your y-intercept. On 4, that would be factored form because it's the two sets of parentheses being multiplied together. So I look at my a value to realize that it's concave up because of that positive 3 in the front there. And then for my x-intercepts, I need the opposites of the numbers in the parentheses. -5, 0, and then -10, 0. Notice how I'm writing my x-intercepts and my y-intercepts as ordered pairs. I always want you to do that. Always write your x-intercepts and your y-intercepts as ordered pairs. On 5, it's one set of parentheses being squared, so that's going to be vertex form. Concave up because of the positive a value of 7. And then axis of symmetry is x equals whatever the x corner of the vertex is. So it's always x equals h. H is the opposite of the number inside the parentheses. So x equals -1. And you need that you need that x equals in order to get it right. You can't just say -1. It has to be the equation of the vertical line that cuts through the vertex. Speaking of vertex, my vertex is supposed to be h, k. So we said h is -1. I don't see a k back here. It's like there's an invisible +0 back there. So our vertex would be -1, 0, because there is no k, so technically there's an invisible 0 back there. On number 6, standard form, so no parentheses, and then concave down because of the negative a value of -3 up in the front there. And then our y-intercept is always our c value when we're in standard form. So y-intercept is 0, -2. For 7, vertex form. It's one set of parentheses being squared. Looking at our a value in the front, there's a -4 there. So this is concave down. Looking at my h value, it's the opposite of the number in the parentheses. So for axis of symmetry, it would be x equals +5 because it's the opposite of the number inside the parentheses. And then my vertex is h, k. So vertex would be 5, -6. Number 8, standard form. So no parentheses. Concave up because of the positive a value of 5. And then the y-intercept is always the c value in the back. So 0, 4. Number 9, factored form. Concave up because of the invisible 1 as our a value in the front. X-intercepts are the opposites of the numbers inside the parentheses. So we have 3, 0 and 7, 0. Number 10, vertex form. Concave up because of the positive a value of 6 in the front. Axis of symmetry is always x equals whatever h is, or whatever the x corner of the vertex is. And the h value is always the opposite of the number inside the parentheses. X equals -8. And then last but not least, our vertex is h, k. So opposite of the number inside the parentheses, and then it matches the k value in the back. K is -1. So -8, -1.